Hello and welcome to Renew, the show about the College of Forest Resources at Mississippi State University. The College of Forest Resources promotes and enables the conservation, management, and wise use of our natural resources. I'm your host, Leslie Berger. Today's show will feature the Department of Sustainable Bioproducts, one of the 3 departments within the College of Forest Resources. Here to represent that department is Dr. Zheling Zhan. Did I do close?
Yes, perfect.
Okay, well, thank you. I appreciate you taking time and coming to visit with us here and to tell us a little bit more about what you do in the Department of Sustainable Bioproducts. So I guess just by way of introduction, I did a little creeping on social media on you, and I found out that one of the things that you research is something called wood-based nanocomposites. So that sounds very sciencey. So what is a nanocomposite?
But recently we actually did a study to convert the wood, use wood as a carbon source to synthesize or to make a nano carbon-based materials.
Okay. So the word nano means very small. We hear nanobots and those
right.
kinds of things.
If you really want to visually to see how big of one nanometer is, people use Earth as a 1 meter, and then the basketball as the 1 nanometer. That's the scale.
Okay, so the relationship
really
of,
small,
of a basketball to the earth is we're talking about a nanoparticle. So you're talking about something that is wood-based. The carbon in wood is used to create these composite materials. But very small composite materials.
Because use what we call a catalytical process. Basically, if you simply say is the catalyst like iron. So the carbon, when we synthesize in certain temperature, the carbon can melt into the catalyst iron. When we load it, at certain temperature, for example, 800 C. But once we lower the temperature, those carbon can release out, then form what we call graphene-based nanostructure materials.
So what do you do with something that is so small? Intuitively you would say that's too small to do anything with, but ideally you're using that to build something that's bigger.
Right. One of the examples actually we are doing now is you can use the nanoparticles to remove the lead, the heavy metal from water. They can replace it. Because it's structure-wise, it's a particle. We form with graphene layers. The core is iron. When we put in the water, they can do the exchange, different reactions. They actually can replace the lead, get into the particle, then the iron can release out. So it's a good application,
Right, so you would use this, say, in a water filtration system, to purify water coming out of a spigot or a refrigerator, or are you talking about something in a different scale, or anything?
In the big scale, and also for the soil, we can remove the heavy metal from the soil also, but it depends on the scale. You can use it for the large scale, because the unique thing for that particle is you can, after you clean the metal, you can use the magnetic to suck all the particles out. That's another interesting thing for doing that. By the way, the products we have actually, there are 2 forms. One is a particle form, one what we call sheets-like, like a sheet.
Very thin.
Yeah, but you can use for composites. That's another application possibly.
Right. And so all of these things that you're building, you are using wood to be able to get the carbon to start this whole process.
In general, wood or forest products, byproducts, for example, lignin, all basically from wood.
So you're not harvesting trees to do this. You were using the residue from other wood products.
And exactly.
Things, so the sawdust or the leftover stuff to be able to use something else from it.
Right. The pattern we have now is we use lignin. That's the byproducts from paper industry. annually, I can give you the number, is like 70 million tons a year.
Wow.
Worldwide. So
It's a lot of product left
yes,
over.
yes. So if we can utilize those waste or byproducts, that'd be really good for the society.
Right. Hence the name sustainable bioproducts. That's
yes,
right.
yes. I mean, our goal is, as a scientist, is how to utilize
Sure.
our resources
Right.
to make a value-added products
Excellent.
for our customers or for society, for users. Yeah.
Right. So I understand your graduate students can be visiting with us, and we're going to learn a little bit more about sustainable bioproducts in just a few minutes when we return after this break.
Want a career as big as the outdoors? Want to have an impact on the environment? The College of Forest Resources at Mississippi State University delivers hands-on training, ensuring clean air and water, wildlife habitats, and a sustainable environment. Creating new wood products and retooling old ones for today and tomorrow. Find a career in whatever path you choose. Majors in forestry, natural resource and environmental conservation, sustainable bioproducts, wildlife, fisheries, and aquaculture. Want a career as big as the outdoors? Choose the College of Forest Resources at Mississippi State University.
Discovery. It tells our history and determines our future. At Mississippi State University, we're digging deep, unlocking an understanding of our past, validating it. Middle East exploration by faculty and students is uncovering evidence that unravels ancient mysteries. Scholars have long thought of the biblical kings David and Solomon as mythological figures. Our research offers evidence that supports their existence, boosting MSU into an international league of experts on archaeology. Now we're changing the way people think about the past, opening up new possibilities of understanding for future generations. Digging deeper, learning more.
Welcome back to Renew. We're learning about the Department of Sustainable Bioproducts at Mississippi State University today. And joining me now is graduate student Arif Kanukchu.
Right.
Okay, well, thank you for helping me on that. I imagine as an international student,
Right.
people stumbling over your name is just one of the things that you have to deal with.
Yeah, it's really hard to say my last name, but mostly people prefer for my first name because it's simple.
Right.
Arif. So yeah,
that
it's
was,
easy.
That was pretty straightforward.
Yeah, it's easy.
My youngest son is actually an international student. He's in the country of Ireland,
Oh, yeah.
where they don't trip over his name perhaps as much as you would coming from Turkey to the U.S.
Oh, yeah.
What are some of the challenges that you've had to face as an international student?
Actually, the culture is different. You coming from the Turkey to here overseas, so the total culture is different, and it takes some time to understand the culture, understand the people. It's really hard to understand in first year, but it's for me my seventh year in the United States, so I understand the people right now, so it's.
Well, sometimes we don't understand ourselves.
Yeah, right,
So
right, yeah.
I suspect
actually,
coming from another
right,
country, it's just
actually.
like these people are really
Yeah,
different.
right, because
Well,
of the culture. I think.
Right. The culture thing is just a huge difference.
Yeah.
But you've stayed, so you got your master's degree, and now you're working on your PhD.
Right.
So evidently you've overcome, and you're clearly successful, or you would not be pursuing your doctorate here. So
Yeah.
tell me about the research that you're doing. I'm assuming it relates to what Dr. Zhang was telling us a little bit ago.
My research topic is about the tensile strength of dovetail joints in furniture.
Okay.
The furnitures has some kind of joints to connect each other, the frame structure. The joint is a very important part, because if you choose kind of weak joints, the frame can damage because of the structure is getting down. So the hard part is to understand the joint structure, like the geometric parameters,
Sure.
or what kind of materials you use, or the size of the materials. It's really important to understand the joints. What I'm doing is we are trying to use some kind of analytical approach, like fracture mechanics methods. This method is help us to understand or predict the load or the maximum load of the joints. So we try to create some equations based on the specific gravity of the materials that we use, or geometric parameters that we use on the joint. So the proper strength design of the furniture structures is really important in making
Sure it is.
in manufacturing process. So what we do also, we also do some kind of looking for the regulations between the specific gravity and the fracture toughness of the materials. Based on these, we apply the regulations to the equations again, and then to predict the maximum load. This will help the people to understand the mechanical capacity of the joints before without the breaking.
Right,
you
so
know.
right, the other way to test that would be
Yeah,
what we think about
yeah.
as traditional, where you'd build
Yeah.
that dovetail joint,
Right, exactly.
and you apply some kind of force,
Right,
and you say,
right.
well, based on that force,
Right.
it was able to withstand
Right,
whatever.
exactly,
But you're
exactly.
using mathematics and
Right,
modeling
kind of,
to
yeah.
begin to predict if
But-
we build
but-
it one way or another
Yeah,
way,
right,
or
right,
use
right.
these different kinds of
Right,
materials,
right.
we can get different
we
strengths.
also use some experimental design and to see the validation between the experimental and analytical result, and then we see how far away from the real results. So
Wow, that was fascinating. A lot of math involved in what you're doing there, I suspect.
right.
But it's very interesting. I appreciate you coming by and visiting with us today and sharing a little bit about what you're doing.
thank
I wish you the very best. I'm glad that you were
Thank
able
you
to
so much.
stay here, and hopefully I'll get to see you again on campus.
Right, thank you so much.
And I also want to thank our guest, Dr. Zahn, for stopping by today and sharing a little bit about the work that he is doing with wood-based nano composites. I hope that you've learned a little bit more about the Department of Sustainable Bioproducts at Mississippi State University, and that you will come back to learn more about us in the future. Until then, I encourage you to get out and enjoy these lovely weather we've been having lately, and I will see you again soon. I've been your host, Leslie Berger.